Review Chapter 8, Right Triangles and Trigonometry. This was a fun chapter. 8.1 was the Pythagorean theorem and its converse. And this is if we know two sides, we can find the third side. So this one has nothing to do with angles. Let's take a look at our first triangle here. We're supposed to find the value of x and express our answer in simplest radical form and rounded to the nearest tenth if necessary. Okay, so how do we start here? Well, the first thing we always do is find our hypotenuse, and that is right here. And we label that C, and our two legs are A and B, and then A squared plus B squared equals C squared. So 8 squared, 15 squared is x squared. 64 plus 225, you should know your perfect squares at least to 15. 20 would be better, but 15 would be good enough. So this is 289 equals x squared. How do we get rid of x squared? We square root. 289 is a perfect square, so x equals 17. So C is 17 units here. And next on the list, we've got a right triangle. So here's our hypotenuse. Label that C, A, and B. And we just do A squared plus B squared equals C squared. So x squared plus 10 squared equals 16 squared. That's 100, and 16 squared is 256. Subtract 100 from both sides. X squared equals 156. So we square root. And 156 is definitely not a perfect square. So we are going to need to simplify our radical. So we factor out perfect squares. So 156, let's see, does 4 go into 156? Yes, it does. So we get the square root of 4 and the square root of 39. Well, I don't think anything goes into 39, so we get square root of 4 times square root of 39. That is 2 times the square root of 39. So x equals 2 root 39 units. And it says put that in to the nearest tenth as well. So if we put that into our calculator, we get 12.489996. So that comes out to be 12.5. All right, Pythagorean theorem, awesome. If you know two sides, you can find the third side. And we also said we can use this to classify triangles. Acute, c squared is less than the legs. Right, c squared equals the legs, and obtuse, c squared is greater than. Oh, come back. A squared plus b squared. So let's look at our first one here. If this were a right triangle, that would be c. So we do c squared equals question mark a squared plus b squared. So 7 squared, 3 squared plus 5 squared, 49, 9 plus 25, 49 and 34. 49 is greater than 34, so it's not right. It is obtuse. And next one, if this were a right triangle, that would be c. So c squared, does that equal a squared plus b squared? So 11 squared, 8 squared, 9 squared, 121, 64 plus 81, 121, that's 145. 121 is less than 145, so that is an acute triangle. And the last one, well, how do we know how big these numbers are? Well, square root of 3 is about 1.7, which is less than 3, and 2 times 1.7 is 3.4-ish. So they're in order. This would be c. So we do c squared. Does that equal a squared plus b squared? So we do 2 square root 3 squared and square root 3 squared plus 3 squared. So what does 2 square root 3 squared look like? Well, the square goes to everybody. Remember your exponent properties. It's almost like distributing. Everybody inside gets squared. So that's 2 squared times the square root of 3 squared. So what does that turn into? That's 4 times square and square root are opposite operations, which means they cancel each other out. So it's just 3, or you can do square root of 3 times square root of 3. Right, square root 3 times square root 3 is square root 9, which is just 3. So this is 4 times 3. So that's 12. And then what do we get here? We have square root of 3 squared. So again, square root 3 times square root 3, square root 9. It's just 3 plus 9. So 12. No, I don't want to write it there. 12 equals 12. This is a right triangle. All right, easy way to classify triangles. 8.2 was on special right triangles. This was our 45, 45, 90. And that's x root 2 on the hypotenuse. That's your hypotenuse. And we had our 30, 60, 90. Was x, 2x, and x root 3. The 2x is the hypotenuse. This is the short leg. This is the long leg. So that's all we have to remember. So let's start here. We want to find our missing length. We have an isosceles right triangle, which means we know that 45, 45, which means we are going to label x, x, and x root 2, which means that we know that x root 2 equals 12. And then we just divide by the square root of 2 on both sides, x equals 12 over square root of 2, which is an answer, but it's bad form to leave that radical in the denominator, so we have to rationalize it. How do you turn a radical into a whole number? You multiply it by itself. So that gives us 12 square root 2, because we just multiply straight across on fractions. Root 2 times root 2 is just 2, so x equals 6 root 2. So that means this side measures 6 root 2 units, and this side measures 6 root 2 units. Okie dokes. And the next one, another 45, 45. It's isosceles, so it has to be 45, 45, 90, which means we are going to label x, x, and hypotenuse is x root 2. And for this one, we know that x equals 4. So this side is 4 inches. Ooh, we should put centimeters on these. X is not 6 root 2 centimeters. X is 6 root 2. So our sides are 6 root 2 centimeters because they are x long. All right, so x equals 4 over here. So that one is 4 inches. And then we just substitute in x. This is 4 times the square root of 2 inches. Yay! Those are the easy ones. This is a shortcut. That's why we do this. Next, we've got a 30, 60, 90 right triangle. First thing that we do is we find our hypotenuse and our short leg. Our short leg is across from the 30-degree angle. So here's short. And our long leg is across from the 60-degree angle. So there's our long leg. And now we label. Short leg is x, hypotenuse is 2x, and long leg is x root 3. And what do we know on this one? X equals 8. So our hypotenuse is 16 inches long, 2 times 8, right? And our long leg is 8 square root 3 inches long. See how easy those are? All right, next one. We have another 30, 60, 90. So we need to identify hypotenuse. Here's our short leg. Here's our long leg. So we label short is x, hypotenuse 2x, long leg x root 3. So what do we know about this one? We know that x root 3 equals 12. Do a little algebra. X equals 12 over root 3. Rationalize our denominator. Multiply across 12 root 3 over root 3 times root 3 is just 3, right? Because that would be square root of 9. And so x equals 4 square root 3. So our short leg measures 4 square root 3. No units on this one. And our hypotenuse, how are we going to do that? Well, we take, what are we going to do this? Right here is fine. 2 times 4 square root 3. 2 times 4 is 8 square root 3. It's not a difficult problem there, so this is just 8 square root 3. Square root is kind of like an x. It's just a number, but because it's irrational, we don't multiply it in just yet. So, easy, easy. If you label your triangles, then everything's easy. The hardest thing to do is to rationalize those denominators. Okay, on to 8.3. Trigonometry. You know how I do enjoy this. So, toa. And don't forget, check your calculator. Sine 90 equals 1. If not, press that mode button. These, if you know a side and an angle, you can find everything else. Or if you know two sides, you can find an angle. That's what makes trig so useful. So first thing we do, we mark our angle. So there's our angle. And we label opposite of our angle, hypotenuse, always important, and adjacent to our angle. So which pieces do we have here? We have adjacent and opposite. So we are going to use tangent. So we write our formula. Tangent of theta equals opposite over adjacent. So tangent of 48 equals opposite is x over 5. We multiply both sides times 5. It's just algebra at this point. And we get x equals 5 times tangent of 48 degrees. And we either just plug that into our calculator, or if we look it up on our trig table, tan 48 is 1.1106. And we get x equals 5.55306, or round segments to the nearest tenth and angles to the nearest degree. So this would be 5.6 units. So this side over here is 5.6 units long. All right, next problem. Mark our angle, opposite, hypotenuse, adjacent. Who do we have this time? We have opposite and hypotenuse, so that is sine. So sine theta is opposite over hypotenuse. Sine 37 equals 12 over x. Now these are, just put over 1. You can cross multiply, or you can multiply both sides by x. It's exactly the same. X sine 37 equals 12. Divide both sides by sine 37, because it's just a number. So x equals 12 divided by sine 37. And if we use our trig table, sine 37 is 0.6018. And x equals put this in our calculator, it equals 19.939 and probably a whole bunch of other decimals. X is 19.9 units. So 19.9, which seems a pretty reasonable number. Our hypotenuse is longer than our legs. All right, the next ones. Oh, what do we do here? Same as we always do. Mark our angle. Here's opposite, hypotenuse, adjacent. Who do we have? We have adjacent and hypotenuse, which means we are doing cosine. So cosine theta equals adjacent over hypotenuse, cosine of x, or theta. We can call it x if you want. Equals adjacent is 6.5 over 10. Now, how do we do this? These are the inverse. To find an angle, x is the inverse cosine of 6.5 over 10. Now, what's 6.5 over 10? 0.65. So we can go look on our tangent table. If we want to use our tangent table, or our trig table, 0.65 is about 49 degrees. If we do it in our calculator, we get x equals 49.4587. That's about 49 or 50 degrees. Would round up to 50. If you look on your tangent table, it's somewhere between 49 and 50 degrees. On your trig table, the closest thing we have is 0.6561, which is 49. So we can call this x equals 50 degrees because we're supposed to round to the nearest whole number. We'll call it 50 degrees. All right, and mark our angle. Opposite, hypotenuse, adjacent. What do we have? We have opposite and adjacent, which means we have tangent. So tangent theta equals opposite over adjacent, TOA. So tangent theta is 7 over 16. So again, when we're looking for the angle, we use the inverse, tan, of 7 over 16. What's 7 divided by 16? If we're using our trig table, that's 0.4375. So on the trig table, if you're looking at your trig table, you have 0.4245 or 0.4452 be 23 degrees or 24 degrees. It's pretty close to right in between those. It's a little closer to 24. All right, if we put it in our calculator, we get theta equals 23.62937. So 24 degrees is a good choice. It's pretty much right there in the middle, isn't it? So x is 24 degrees there. All right, trig is easy. Don't be afraid of it. As long as you mark your angle and label opposite, adjacent, and hypotenuse, life is good. And then choose which SOHCAHTOA you want. Okay. Oh, we're going to do a real problem here. 12-foot ladder is propped against a vertical wall. So here's a wall, here's the ground, here's our ladder. Vertical means it's a right angle. What do we know? We know that our ladder is 12 feet. The top end is 11 feet above the ground, so there's 11 feet. What is the measure of the angle formed by the ladder with the ground? So there's theta. So mark our angle. Opposite, hypotenuse, adjacent. We have an AH. No, we don't have an AH. We have an OH. Opposite and hypotenuse, so that means a sine. So sine theta equals opposite over hypotenuse. So sine theta equals opposite is 11 over 12. Looking for an angle, so theta equals the inverse sine of 11 over 12. If we're looking on our trig table, that is 0.9167. On our trig table, we find 0.9135 is our closest, and that gives us 66 degrees. And if we put it into our calculator, theta equals 66.44. So theta is 66 degrees. Has a 66-degree angle with the ground. And 8.4 was on angles of elevation and depression. It was just more trig, only real world problems. So your friend is flying a kite, lets out 105 feet of string and ties it to a 3-foot tall pole. So we've got a kite. It's tied to a pole. There's the ground. We can draw a little kite up here. Doot, 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 doot. What do we know? We know this is 105 feet of string. We have a 3-foot tall pole, and determines the angle of elevation. Angle of elevation means that we've got a horizontal and we're looking up. So that angle there is 48 degrees. So there's our angle of elevation, 48 degrees. How high is the height above the kite above the ground? So that's our x feet right there. All right, we mark our angle. Opposite, hypotenuse, adjacent. We are looking at opposite and hypotenuse, so another sine. So sine theta is opposite over hypotenuse. So sine of 48 is x over 105. Oh good, these are easy when x is on top. We simply multiply. X equals 105 times the sine of 48. If you're using your trig table, sine of 48, 0.7431, or using your calculator, x equals 78.0302. So this is 78.0302 feet, or 78 feet. But that is not the total height of the kite. Don't forget to add on the 3 feet from the pole. So we need 78 plus 3 is 81 feet above the ground. Okay, and our last problem here. Couple is taking a balloon ride. So they've got to make our balloon more balloon looking. Our light bulb slash balloon picture. All right, they're taking a balloon ride, and when they are 108 feet above the ground, they measure the angle of depression. So angle of depression means we're looking out at the horizontal, and angle of depression is measured down. So that means we're looking at that angle right there. So they are looking down at their launch point, and they measure that angle is 16 degrees. So that's 16 degrees. Because here's our horizontal. Ooh, I'm doing this wrong. Ay, caramba. There's our horizontal. This angle here is 16 degrees. Right? That's the angle of depression. We want the horizontal distance from the balloon to the launch place. So we are looking for this right here. We know they are 180 feet above the ground. We are looking for that right there. So we know by alternate interior angle theorem that this measure is 16 degrees, right? And mark our angle, and we get opposite and adjacent. So we would use TOA. That's not much of an O there. And you could write it just as it is, and that would be fine. And what we would get is the tangent of 16 equals opposite 180 over adjacent x. And then you know you have to multiply across, and everything gets really hard, right? X tan 16 equals 180, divide by tan 16, divide by tan 16, and x equals 180 over tan 16. Well, I don't like that. What I'm going to do is I'm going to measure this angle up here. What does it measure? 74. Then this becomes my opposite. This becomes my adjacent. I am still going to use tangent, but now tangent theta equals opposite over adjacent. And I use tangent of 74 equals x over 180. Isn't that so much nicer to put x on the top? So now x equals 180 tan 74. So if I do that on the calculator, I get x equals 627.7345. And guess what? If you do x equals 180 over tan 16, guess what you get? 627.7345. You get exactly the same answer. So they have traveled 627.7 feet from their launch point. But do you see what kind of difference choosing your angle makes? We know that our triangle has two angles, right? And so the angle of depression was 16, so alternate interior moved it down here. And I realized I need opposite over adjacent. That's going to put 180 over x. I don't want that. So I changed my angle so that opposite over adjacent was x over 180. Both ways you get exactly the same answer, but as in life, making good choices at the beginning makes everything go easier down the road. So that's chapter 8, Pythagorean theorem, special right triangles, and SOHCAHTOA, trig. All of these are easy if you are careful and label, label, label. So good luck. I am sure you will do very well.